Here are 3 examples of polynomials that a lot of times students confuse as not being polynomials because they remember these kind of 2 rules. 1, you can't have a variable in the denominator, or you can't have a negative power as your variable. And then 2, you can't have radicals on your variable or rational powers for your variable. But if we look a little bit closer here, what we realize is all 3 of these actually do not satisfy any of those conditions. If you look at over here, yeah, I have a denominator, but I don't have a variable in the denominator. 5 is in my denominator. So I could also just rewrite this as a y equals a 1/5 times x to the 4th minus 3x squared plus 1. And again, that is going to represent a polynomial. Now, in this next one, people see the radicals and immediately they think, oh, we have radicals, therefore it's not a polynomial. But that is only the case when we have a variable is raised to the radical. So if I had y equals the square root of x, that is not a polynomial. Or if I rewrote that as rational powers, that would not be a polynomial. But if you look at my x, I have an x squared, I also have an x to the 1st power. So we're still looking good. The other one that throws students off is having an irrational number as part of our constant. But again, that is not going to actually direct anything with our 2 variables. So ladies and gentlemen, this is still going to be a polynomial. And the last one doesn't look like a polynomial at all. But if I wanted to rewrite this with an x, I could say x to the 0 power times 4, or y equals a 4 times x to the 0 power. Then we look by inspection with the x. Is x in the denominator? No. Is it having negative power? No. Does it have a rational or is it a radical? No. So ladies and gentlemen, these are all 3 examples of polynomials. Don't get confused when your teacher is trying to get you confused.